Hi pen fans, this is Brian at the Edison Pen Company. I hope that everybody is doing really well. Hey, I would like to share a film with you or a video with you that is going to outline how we make a Menlo pump filler from beginning to end, starting from raw acrylic to a finished product. In the past, we've done some behind-the-scenes videos, and I think that people really appreciate when we do those, because you get to see a little more insight as to the construction of these pens, what goes into them, and you kind of get a full appreciation as to what we go through and how we approach the design as well as construction of these. So I think you'll enjoy this. Sit back, relax. This is the making of a Menlo pump filler.
Okay, so there's three main types of Menlos that we do, and the three different types have a lot to do with whether or not you can see the ink levels. The first type that you're looking at right here is where we have solid caps, solid blind caps, but an ink view barrel. You can watch the pen fill, you can tell when your ink levels are low. The next type that we generally do is all solid, or all, a material that is non-translucent. A lot of people prefer this look, and seeing the ink is not necessary, but a lot of people find that seeing the ink is pretty cool. So that's the second option. The third option that we generally do with these pens would be exactly what you see here, where the entire pen, everything is translucent. On the left you can see solid colors, and then on the right you can see swirl translucence. So it's kind of like a demonstrator with character, if you will. And that's exactly what we're going to focus on for this film. The pen that we're going to make is this right here, which is a Menlo in an amber swirl translucent. You can see the mechanism, you can see the nib, you can see how the clip attaches, you can see all that engineering in there. These have been pretty popular. I think that the other reason that we're using this pen is because you can see inside, and it makes the purposes of this video a lot more interesting, because when you can see the interior, you understand better how we're doing this when we go to actually make the pen. And here you see the whole reason that the translucents are popular generally. Watching the pen fill is pretty cool. Now in the case of this one, this is a solid gray translucent, not the swirl that we're doing, but you get the idea. Okay, let's get started. This is our raw material for the amber swirl translucent. I think you can see it's very rough. There's saw marks on the front from when we put it on the table saw. I wanted to backlight this heavily so that you could see how the material, even in its raw form, is translucent. This is a really neat material, one of our personal favorites. But this is what it looks like when it is in the raw. Okay, so here we are. This is actually my GoPro inside our numerically controlled lathe. That's the material. We get this chucked up into the chuck. I think if you look there, you can see from left to right there's 9 tools that is used within this lathe. It is numerically controlled, so with pens like this, it's a program that we write to make these specific parts. Right now, what I'm doing is doing the first operation on a barrel. Generally speaking, first operations are when you do the interior, and then second operations are where you do the exterior. So what's happening right now is we are creating the face of the piece. We're taking the face and getting it nice and perfectly smooth on the outside, or on the edge right there. Now the drill is going in, which will hog out a lot of the material for the interior, or the bore of the barrel itself. Now a drill is a very rough and imperfect tool. It just basically hogs material out, but it never leaves anything remotely resembling a clean surface. That's why this tool goes in, which is called a boring bar. The boring bar has a cutting edge on one side, and it goes in and makes a much more precise hole than what a drill does. And right now I'm creating the internal bore in preparation for threading. So actually the section is going to screw into this portion, and right now it's being threaded. So the threads that will accept the section are being cut right now. And right now what we're doing is we're doing one final pass of the bore for the interior. Because this pen is rather translucent, I like to make a final slow pass to keep the interior as clean as possible. Now this still will leave it relatively rough. There's still a lot of internal work to do in spite of that. which we'll get to in a second. Now at this point we're going to start shaping a little bit of the outside. You can see that right there, that tool just turned this piece from square to round on the edge, and it is starting to create the shape that we need right on the front, and it's also creating the exact diameter for where the barrel threads will go. And these barrel threads will be coming in just a second. I think that it'll happen right about now. The threading tool goes in and will create the exterior threads. So these are the threads that the cap will attach to. And once these threads are finished, then the tool on the far right, which is called a parting tool, will come in and cut this piece off. Pull the stock out to that length, and then the parting tool will come in and snap the, I shouldn't say snap, but it'll cut the piece off. Watch it disappear here in just a second. Falls down below where I grab it, and you'll see that right there. That is the first operation done on a Menlo barrel. Now it is time for the second operation on this barrel, and what we use is called mandrels. You need to invent ways when you're making pens. That's the mandrel right there. You need to invent ways when making pens to mount a piece on the lathe in a way that does not require it being held by the chuck. So what we did is we screwed the piece onto this mandrel, mounted it into the collet, and now we can work the entire piece without having to handle the piece itself by the chuck. So what we're going to be doing right now is we're going to create the threads that will accommodate the pump mechanism. So this is the back of the barrel that we're working on right now. Again, this first tool goes in and faces off, or makes a perfect smooth face on the front. Now this drill is going to go in, the same as before. It's going to hog out the material, knowing of course that it's not making a very accurate hole. The boring bar, which is this tool, will now go in and create a very smooth surface and exactly perfectly the diameter that we need. Like I said, this is the pump end of the barrel, if you will. So right now what we're doing is creating what will be needed as far as bore and threads to take the pump mechanism. And right now we're cutting the interior threads. So the pump mechanism will screw into these threads right here. And now that that is done, it's time to shape the exterior. So this is all square, and it just now turned round, and the shape is going to continue here. I will mention, just for the sake of this video and not taking up literally, a half hour or an hour or longer with this video, I'm only going to show you the actual machining of, on this lathe, the actual machining of just the barrel. If you can imagine, the first and second operations for other parts are very, very similar to what you're seeing here. The first operation, the interior gets worked on. The second operation, the exterior gets worked on. So I won't bother showing you, the cap, the section, the blind cap, cap lip, all the other parts like that. Just understand it looks awfully similar to this. We'll just outline a barrel for this portion. So you can see how what's happening right now is that tool is slowly bringing this down to the needed shape, and once it gets there, I'll show you what we have. This is almost finished. There will be one more final pass that's a little bit slow to give this hopefully a cleaner finish. Of course, it will never come off of this machine completely finished. It'll always be rough, and then it needs to be sanded, filed, polished from there. But you get the idea. This part is almost finished. There we go. So that is a barrel with the first and second operation done, ready for polish, sanding, and assembly. Okay, we've done a bit of fast forwarding. Front and center right now is that barrel that I just showed you. But what I've done is I've gathered up every component that goes into the Menlo, and then I have it outlined here or shown here. The majority of these parts will come off of the NC lathe looking like this. Now they look pretty good right now, but trust me, if you saw these live, they're pretty rough. There's no sanding, there's no polishing, they're not shiny. But this kind of gives you an idea as to all of the components that go into this before we go to do our sanding, polishing, and assembly, which I will cover right now. Okay, so now we're at a point where we get into a lot of the manual work that goes into these pens, and a lot of the reasons why we really cannot mass produce these pens as well. I'll get into a little bit of a discussion about the difference between injection molding and machining pens, as this is really what's critical. What I'm going to be doing right now is taking this boring bar and manually going in and cleaning up the interior of this pen. It's a snap to polish the exterior of a pen. That's, you can buff, you can polish, you can sand. That's easy on the exterior. What's really difficult is the interior. Now, injection molded versus machining, and the reason that we can't really do these on a mass large production scale has a lot to do with what I'm doing right now. If a pen like this were being injection molded, then you could mass produce these and you could do them really fast and you could crank them out, no problem. However, injection molding will never lend itself to a material that has any kind of swirl, grain, color. Injection molded plastic, and I could be mistaken, but to the best of my knowledge, injection molded plastic will always be, like a solid plastic, a solid translucent. You can never get these swirls in here because those swirls are cast into the material itself. So that really is the trick. So right there, I've gone in and I've went ahead and did a more precise cleaning of the interior. And now you can take a look. It's a little bit cleaner. You'd have to see this live to really appreciate it. My camera isn't picking this up, but it's a little cleaner on the inside, and now it's time to start some sanding and polishing on the interior, which is what's going on right now. This is basically a homemade tool that holds this sandpaper. Back to the injection molded versus machining issue. If this were injection molded, all of this work that you're seeing right here would not be necessary at all. The parts would come off of the injection molder looking very, very clean on the inside and probably would require no polishing, no sanding at all. I'm not an expert on injection molding, however, since obviously all that we do here is machining, but that's my understanding. So now the downside, of course, is that you're not going to get any interesting, well, I shouldn't say interesting, but you're not going to get any material that has a bit of character to it, like this crazy swirl that you see right here. So anytime that you see a pen like this that has that is translucent, but yet still has some pattern, some swirl, some grain to it, you know that there's a lot of work that went into getting the interior done. And I think that, here at the Edison Pen Company, we're one of the only pen companies that really take the time to do this with these types of pens. Materials that are largely translucent, that are also cast, that have swirls, that have patterns, that have a lot more interesting things going on in the interior than just a solid color or a clear material. So you kind of get the idea as to what our process is here. I'm going through a series of sandpapers, going from a rougher grit to a finer grit, and then I will eventually make my way to a little homemade buffing bob, which you'll see shortly. But really, this is all that extra work that is required, and it's not just the translucent materials that really require this. The non-translucents also need a pretty nice surface inside as well. Not quite as much work as what you're seeing here. The translucents definitely require a lot more work, but even the non-translucents, we can't just go straight with a drill. We need to have a little more precision on the interior of those. So hopefully this gives you a little more insight as to why we really can't mass produce these. There is, you'll see there's a lot more to come, but this type of work right here is exactly why, we really can't introduce these pens to our production line. The pens that we can kind of do on a mass scale. This is the type of pen that there's a lot more labor involved, a lot more handcrafting involved. getting the interior of this perfectly polished on the inside as well as the outside. That's what the trick is. And now I've moved on to the little buffing bob. This is a homemade tool that will get my interior buffed as well as the exterior. Another note that I should make here is that understand that the exterior of this pen actually has not been sanded yet. So it may not look that impressive. All this interior work that I'm doing may not look all that too impressive so far, but I think that the main reason for that is because the outside surface is still rough. It's still not perfectly clean on the outside. It's important that we do this interior work first. I can't do this interior work after the pump mechanism has been installed, so I have to do this first, and then we move on to the assembly and sanding, polishing, and such, which you'll see shortly. And it also should be mentioned, for the sake of the video, I won't cover the exact same procedure for the cap, the blind cap, and the section, but understand that all this work that you're seeing right now is we're just showing it on the barrel. The same thing has to happen to the cap, the section, and the blind cap. So it really does turn into a lot of work, and again, doesn't lend itself to mass production. But that's the barrel with the interior finished. Time to do some assembly. So here I am at my bench, ready to assemble the pump mechanism on this. You can see some of my parts there on the left. Right now I've got the diaphragm, which I'm going to snip to the appropriate length for this mechanism. I then have this tool that I will use to push the interior pellet. I'm going to stretch it, take a look at it, make sure that there's no holes, any rips or tears, and then I'm going to install this into the cup of the pump mechanism. There you go, nice and secure. Now it's time to essentially unroll the diaphragm onto itself, which is a little difficult unless you use a dry lubricant, which I'm doing here. I have this tool, the other end of this tool that I was just using. I will put baby powder on it and slide this over top, just basically a dry lubricant, and then I will coat the exterior of that with the same baby powder so I can do this, which is basically unrolling the diaphragm onto itself. Without that lubricant, the latex in that diaphragm would be way too sticky and I wouldn't be able to get that unrolled onto itself. And there we have that mechanism pretty well assembled with the latex diaphragm. You can see our employee Wendy in the off to the left there. She is actually running the machine that that you just saw that the GoPro is inside. So that's the numerically controlled lathe that you see her operating off to the left. I'm using a lubricant. Now this is a wet lubricant as opposed to a dry lubricant. This serves two purposes when I'm installing this. Number one, it makes the insertion of the diaphragm a lot easier, and then at the base it also creates a very, very nice seal against the interior bore that we created on the lathe. So that will screw in. I have this specialized tool here that gets a really good grip on it. There's really no, you couldn't do this with your fingers at all. You have to have this specialized tool to do this. A lot of the pen repair guys have these tools. Actually, any pen repair guy that works on vacuumatics would definitely have this tool. It's absolutely essential to do that. There are different variations of this tool. This is my preference, though. I like this one. The other ones that have like a wrench handle, I think that they have more of a tendency to it's a lot easier to strip threads with those tools. This one doesn't have as much travel, and so it doesn't rip out those threads at all, as opposed to the other tooling. And now with that mechanism installed, we can attach the blind cap. Okay, and now it is time for a compression test. When engineering these pens and when manufacturing these pens, it's absolutely essential that the pump mechanism is completely sealed off. If there's any kind of an air leak happening through that, then obviously the pen will fail. It's going to, if you have an air leak, then you don't have a sealed chamber and ink will just literally fall out the nib. So what I do is I take this bulb aspirator, put the end of the pen into water and squeeze. If I see bubbles, then I know I've got a problem. If I see no bubbles at all, then it's completely sealed off. Okay, so at this point, as far as sanding and polishing goes, we've only done the interior, the cap, the barrel, blind cap, cap lip, and section have all been cleaned on the interior, but now it's time to work on the exterior. And this is my wife working on this one. I think that you can see the same as I showed you with those mandrels. The mandrels that we use on the NC lathe for doing second operations, well, we do the same thing on these lathes, which are smaller manual lathes. It's just a very, very easy way to hold these work pieces without having to put them in a chuck. So my wife here is taking the shape to a final shape, getting rid of any imperfections that would have been left by the NC lathe, and using a file to get those the way that they should be. And now it's time to move on to sandpaper. We start with a really rough grit to get rid of any of the scratches that the file would have left, and then move up through very, very fine grits. And here you'll see my wife is doing the same thing to a cap. Starting with a series of coarse grits, and then moving up to a series of fine grits. The sanding process is essentially just replacing coarse scratches with finer scratches. You have to do it incrementally. You have to start with a coarser grit, move up one step, one step, one step, and essentially you're just removing coarse scratches with finer scratches, eventually getting to the point where the scratches are so fine that they're imperceptible. What I said about finer scratches replacing finer scratches applies of course to sanding, but it does apply to buffing as well, which is the next step. We apply a compound to the buffing wheels, and that compound is an abrasive. So really what we're doing is, even though our finest grit sandpaper might be pretty imperceptible as far as the scratches go. I mean, sure, on a microscopic level, you're still going to see some scratches going on, but when you get to a buffing wheel, we're using this compound, and this compound is really doing the same thing, but on an even finer scale. The compound is replacing those scratches with even finer and finer scratches. So here we move on to a different compound that is even finer than what we had before, and this is really the final step for polishing. We don't apply very much of this compound because it's not needed. The final step really is on a buffing wheel that has very, very little compound, and by this point, once you reach this shine, you've really gotten to a point of where even on a microscopic level, there's nothing to be perceived at all. So we've gone from very, very, very rough scratches that a file would use to a completely perfectly shiny surface. At this point, from applying the compound, and even though we buff all of it off with the buffing wheel, of course, there are portions where that compound can stick, namely threads. So all of our interior threads as well as exterior threads require some cleaning. So we take a brush, interior brush and exterior brush on a dental tool such as this, and get all those threads nicely clean. So a little fast forwarding, all of the parts are now polished and looking great. And just basically you put all those parts together and you have the pen. The barrel's already assembled, the section screws in, the cap lip captures that center band, and then it's time to test the filling mechanism. The people that love these translucent pens, this I think is the reason why. Watching this pen fill really is super cool. Watching the ink kind of go up and down the breather tube and spill into the reservoir, that's really neat. And personally, I agree with the people that really appreciate these pens for that reason. I also love translucent pens, not just to watch them fill, but as a person that engineers pens, I love to see the interior, to get an appreciation for how they attached this part, how they put the clip on, how they, basically a pen that has lots of translucent qualities I really like a lot, because I can see all the engineering that went into it, let alone the ink and what the ink levels are, and kind of seeing the ink slosh around. I think that's pretty cool too. So at this point the pen is finished, but like any Edison pen, we will not ship a pen without tuning and testing the nib first, which is what I'm doing right now. Tine alignment as well as smoothing. When I first tested that nib, it seemed a little dry, so I made that nib a little bit more wet, gave it a little bit of work on some micro mesh and then mylar paper. The tines were already aligned, so I didn't need to do anything major with that, but that's what that loop there is for, is to check out the tine alignment. So that nib is writing very well. And here is the finished pen. I decided to photograph this with ink inside the pen. You know, a lot of times I rarely photograph these with ink, because when I'm shipping these to clients, they might have their own personal preference as to what color they would like or what ink they prefer. Of course, I don't ship pens with ink in them, so since I rarely photograph pens with ink, I thought I'd include it here at the end of this. So thank you so much for watching. If anybody has questions or comments, please leave them in the comment section of wherever you're watching this, and thanks for watching our video on how we make a Menlo pump filler.